After 10 years fighting back photons in its peripheral vision, a NASA space telescope now has a way to use nuisance light to potentially increase its science productivity. NASA's NuSTAR, Nuclear Spectroscopic Telescope Array, X-ray Space Observatory successfully gathered information about a superdense star, known as a neutron star, that was in its peripheral vision. Engineers say the design quirk of NuSTAR ended up being a boon in looking at the object, SMC X-1, in X-rays. Neutron stars, which typically occur after supernova explosions, trap gas particles with their magnetic fields. The X-rays are generated as the particles are accelerated and energized during a journey to the star's surface. This paper shows that this stray light approach is reliable, because we observed brightness fluctuations in the neutron star in SMC X-1 that we have already confirmed through direct observations, lead author McKinley Brumbach, an astrophysicist at the California Institute of Technology in Pasadena, California, said in a statement from NASA's Jet Propulsion Laboratory, JPL. Going forward, it would be great if we could use the stray light data to look at objects when we don't already know if they're regularly changing in brightness, and potentially use this approach to detect changes, Brumbach continued. NuSTAR launched to space in 2012 to study the cosmos in high-energy X-rays, providing a valuable addition to the study of SMC X-1. Its X-ray output pattern was finally established in recent years, following decades of work by NuSTAR and other telescopes to determine how often it changes brightness and why. Scientists have pinpointed several reasons why SMC X-1 changes in brightness when studied by X-ray telescopes, JPL stated. For example, the X-ray's brightness dims as the neutron star dips behind the living star with each orbit. The stray light data was sensitive enough to pick up on some of those well-documented changes. NuSTAR's stray light situation comes from a design quirk. The dumbbell-shaped observatory includes a 33-foot-long, 10-meter-long, boom and two bulky areas on either end. The observatory typically observes by pointing one bulky end, with the optics. As the light is gathered, it travels and becomes precisely focused through the boom before arriving at the detectors, situated in the opposite bulky zone. Unfortunately, nuisance light constantly enters the detectors through the sides of the boom as well, creating a faint circle of light on the sides of images. In recent years, NuSTAR team members began using computer models to predict the amount of stray light from various known X-ray sources. The result was an 80-object catalog with stray light observations, nicknamed StrayCats. While the stray light does not replace direct observations through the boom, several Caltech students did examine the StrayCats catalog and found examples of potential science, such as rapid brightening that might be attributable to neutron star surface explosions or other events. Tracking this behavior will add more information as to how neutron stars behave, the team said.